Hello everyone. Let's start our today's session. I am sharing my screen. Please let me know if it's visible to you. So guys, any doubt in earlier topics? We are continuing after such a long break. Please let me know in earlier topic any of you have any kind of doubt. Last we have visited VPN connections. VPN we have seen how to configure VPN virtual private gateway and VPN connection and the customer gateway. So any doubt till now, guys, please let me know. Today's topic is load balancer. It is again a very important topic. So in AWS, we have many different kind of load balancer. One is not mentioned over here. It is gateway load balancer. So application load balancer, network load balancer, classic load balancer, and another one is gateway load balancer. So we have many different type of load balancers, and all of them are doing the same work. If we have certain servers in our environment and they are publicly accessible, so we want that if we are dealing in high priority, if we want that our services are high priority and we decide that we are not going to shut them down, so if the demand for our service or our web server or our website, whatever resource you are holding and hosting over there, what you want that they are always accessible. So for that, what is happening, we have multiple server and there's a load balancer. And if it is dividing the role of load balancer, we all know that it divides the request. So we will see how the load balancer is working in AWS and what is the working and how we can configure our own load balancer. Okay, so the main topic is the network load balancer. Its work on the TCP layer, transport layer. So let's understand, guys, what is network load balancer. Load balancer distribute the web traffic to the available server. We all know that this is a very simple definition. This is what load balancer stand for. This is what their purpose is. So what they do, they distribute the web traffic to the available server. If we have 4 server deployed in our environment and we have a load balancer too, so one by one it will forward the request to the freer server, the server which is available to send the request and to receive the request, it will send it to. A load balancer server are the single point of contact for client. So we know that there is a load balancer. We know that there are multiple server, but client doesn't know that there are multiple server. He just hitting the same address and the result is eventually same for him. So the client only has a single point of contact. He doesn't know what is the working behind. So what it is indicating, when we deploy load balancer, when we do all of this configuration, our process will be so smooth that the party who is involved will not even notice it. Okay, the load balancer distribute incoming traffic across the multiple targets such as Amazon EC2 instances. Okay, so guys, there are two type of thing that we have to understand. The working of Amazon load balancer. In the Amazon load balancer, specifically in network, we have two type of thing. We have our listener and then we have our target group. So listener, eventually we are listening to some communication. Load balancer is receiving the communication first, then it is r- then forwarding it to somewhere else. So load balancer, it doesn't have any data, it doesn't have anything else that it can compensate with. It can only take the request and it can send it out to the relevant party. What is the relevant party? The available server. So uh, listener, in the listener condition, what we do, we allow the ports on which port we want to listen the traffic, what kind of traffic we want to listen. So let's say I want to listen all TCP traffic, I want to listen all HTTP traffic, so I will open the HTTP target, like listener port, and then the port as well, HTTP and the port. So that's what listener do. They listen to the traffic, what kind of traffic, what kind of port. Okay, then they forward it to the relevant party. And what is the relevant party? Our relevant party is the target group. So we will be configuring the listeners, we will be configuring the target parties. So don't worry about that, but just remember how the load balancer is doing its work. It is listening to the traffic. It is then determining what kind of traffic is it. Is it a TCP traffic? Where I should forward it? What kind of port it is using? So that's what it is doing. After determining all of these things, it will forward the packet, forward the traffic to the available server. That available server should be the part of the target group. Okay. So now let's see the definition. The load balancer distribute incoming traffic across the multiple targets such as Amazon EC2 instances. So target, what target? Amazon EC2 instances, our web servers. So this increase the availability of your application automatically. If we have multiple server and we have a load balancer who is dividing in between the availability, then it means that we have a higher availability than before. Okay. You can add one or more listener to your load balancer. So you can add just one or more if you want. So these listener are nothing. They are just, we are letting it know that we want to listen this kind of traffic on this particular port. Okay. So let's say I want to open TCP, and I want to select port 80. I don't want HTTP. I want TCP to work on port 80. I can do that. Okay. So a listener checks for the connection request. That's I have been telling you. A listener checks for a connection request from clients. It can be anyone using the protocol and port. What are the two important things? Protocol and port. You configure and forward request to a target group. So load balancer will then transfer the request to the target group. Each target group routes requests to one or more registered targets. So we can register many targets, and there are many groups we can create, and then we can forward the traffic according to us. Okay. So it's all depend how we are configuring it. Okay. Such as EC2 instance using the TCP protocol port number you specify. So whatever we specify, that will work for the load balancer. Best practices is to place your server in different availability zone. So it's just telling you what is the best practice should look like. If you are creating different server and you want that a higher availability, then what will you do? You will put those server into different availability zone. Let's say if there are some mishappening and some disaster that will create the loss of whole availability zone A, then we can recall our resources from availability zone B. Okay. So for the replication we can do that. This is also why it is called best practice. Now, network load balancer. Our network load balancer functions at the fourth layer of the open system OSI model. Okay. So on the transport layer, the layer on which TCP work, the load balancer works on the same layer, network one. Okay. So it can handle millions of requests per second. After the load balancer receive a connection request, it selects a target from which target group. For default rule, it attempts to open TCP connection to select target to the port specific on the listener configuration. So it will select the target group after listening the port specification and connection specifications. Okay. Guys, load balancer facilities are not free in AWS. So if you want to check, you can check the pricing. Uh, Okay, so let's come on to the network load balancer. Again, we talked about network load balancer. So network load balancer works on the transport layer. Application load balancer, as the name is suggesting, works on application layer. So we have many, we have two other types of load balancers also. When we will do the lab, we will see that. Before going to the lab, let me tell you just one another topic, which is auto scaling. AWS auto scaling monitors your application and automatically adjusts the capacity to maintain steady, predictable performance at the lowest possible cost. So, guys, load balancer is distributing the traffic. Okay, it is distributing the traffic amongst the different instances. But what if the number of instances we have deployed are not enough? The load balancer is doing its work perfectly, but we have low capacity, we are low on resources, we are running low on resources, we don't have more server deployed, that's why we are not able to fulfill the request. In that case, we come with the option of auto scaling. What is happening in auto scaling? We have a certain image, and we have some certain configuration that we have selected. Whenever, let's say you want that whenever 80% of CPU utilization is there for almost 1 minute, this is what all you have to do. You will decide it by yourself. On what premises you will be deciding. Okay, so what you have to decide, let's say I have a particular server, and that server is now deployed and 80% of its CPU is now utilized. So I know after 80% and it is working on 80%, so the chances of it failing is pretty high. So what I want, that whenever any of my server reaches to 80% of CPU optimization, what I will do, automatically a new group of instances, a new group of resources will deploy by itself. We will configure it in such a way that whenever we are facing high demand, even with low, like even where load balancer is working, even our all servers are working right now, but still we are facing high demand. That's why whenever this kind of situation arises, we want that without facing the loss of failure, another server should be up and running in case whenever it is needed, and when it's needed in case of high demand, in case of high web traffic, when we are receiving high web traffic and our current resources, our current servers are not able to execute the request. In those cases, a new server should be deployed and should be get in the up and running state whenever we feel such high traffic. And the range of traffic you can adjust. If you want that whenever your server is working on 80% CPU, then automatically one or two other instances should be launched automatically. You can configure that in auto scaling. Okay, so you can use auto scaling to manage Amazon EC2 capacity, automatically maintain the right number of instances for your application, operate a healthy group of instances, scale and according to your need. So you can increase the number of instances automatically, and you can also decrease the number of instances. Let's say now I am only using 40% of the CPU. What is happening now? I have a lot of resources that are not in use right now. So another EC2 instance is also not in use. What I do? All the extra instances, I will close them up. So rather than doing it every time I face this kind of issue, I will configure auto scaling, and auto scaling will do it for me. I will give them a baseline, that this is my baseline, and you have to act accordingly. If you feel that there's an increase, then you will increase the number of instances, but if you feel that there's a decrease in particular situation, you will decrease the number of instances. Okay, any doubt, guys? We have covered two very important topic, and we have to move forward towards the lab. So before doing that, please let me know any doubt, guys. Network load balancer, auto scaling, these two we have to do now.
Okay, so in auto scaling, we are not increasing the capacity of the resource itself. Like we cannot increase the capacity of the processor directly, but we are
You
creating a
can.
new machine in itself, and that
Mm-hmm.
is doing the job
Yes.
with the help of that load balancer. It means in auto scaling cannot work without a load balancer also, right?
Now it can work without the load balancer. So load balancer is just forwarding the request to the available web server. Okay, that's what is it is doing. But if you don't want any load balancer, but still there are three server, and you want whenever these three servers are working on it highest capacity, you want that another set of three servers should be up and running. So you can configure that. There is no need for load balancer, but the both of these two are used together because they do provide a higher rate of availability and the loss of request. Okay,
But in that case, how will the newly created servers will be available like? without load balancing because there is only single point of contact, and we have three servers running in the initial state. When the usage increased and it created three new servers. So will it shift the availability among the six servers without load balancer?
Okay, so let's suppose that you only have one particular server. So like for one server, you will not use load balancing, right? Yeah, but you do want that whenever your that particular server is working on its highest capacity, there should be another server should be up and running, right? There can be cases like that.
Yes, but again, if even it is only the second server, it
Mm-hmm.
cannot be used without load balancer, no? Like
Yeah, that's totally understandable. But like, do we like if you want to set up one server, do you have to set up the load balancing? That is not, like, we can use auto scaling without the load balancing. That's what you have asked.
even in practical way, not theoretically, because
Yeah.
it cannot be of any use actually actually, na.
Yes, yes, yes. No, like normally if you this kind of question come in the exam and if you write no, then it will like it will create a blunder. You have to explain that no, if we have just one server, we can use auto scaling without the load balancing. This is the right answer. Like we can
Okay,
use
okay, yeah,
auto scaling without
understand.
the load balancer.
In that case, does it bring up another server or just the resources of that server expand?
No, it will launch a different instance, a new instance.
Okay.
Okay. Yes. Yes, guys. Keep bringing your doubts. Otherwise, we are moving towards the lab. Okay. So, guys, you can see we are in our EC2 dashboard, right? And these are the few topics which are left. Load balancing, you can see load balancer target group. We discussed this. Let's open up the target group and let's create our first target. So you can over here see that I have already working with some specific targets. I will create the new target group for you. So we will do all the work. So we are creating it for the instance, and let's not focus on the other details because they are the advanced. They are operating on advanced level. So we are configuring the instance first. What we have done, we have in our EC2 console, and then in our load balancer option we have opened up our target group. Okay, so now we are creating a target group instances. Okay, let's see specific group detail. Your load balancer routes request to the target in the target group and perform the health check on the target. So health check is like health check is just simply when you ping some system to see if it's connected to the internet or it is available on the network. Similarly, we do the health check to check if it is working properly, if the load balancer is able to distribute the resource request. Okay, so this is what we understood with the health check. We are checking the health of load balancer. Okay, now basic configuration. Target type, we are using instances because we are talking about web servers. So over here you can see target group name. You can add any. My target group one. Now talk about the port and protocol. Which protocol and port should be open? Over here the HTTP is open, so HTTPS if you want, TCP if you want, TCLS if you want. So let's take TCC. Okay, TCP, and then we have to select the virtual private cloud. So over here there is a default one. Okay, I don't want to select the default virtual private cloud. Let me just create one real quickly. Okay. So guys, I'm creating my virtual private network. So I'm not going with the default, because in the default one there are certain configuration that are allowed, but I want to show you each and every configuration right here, right now. So let's just create the VPC. My VPC, let's take the CDR block. Likely we have to create the subnets also. We have done all of this configuration before, guys, so I'm not explaining. But if you see something that you don't understand, please let me know. So we have one VPC and one subnet and one gateway up and running. Okay. So let's see, network ACL. We have our network ACL as well, security groups. So coming back to the we have to do this again. So let's refresh this page. So for health check, guys, we have to write a ping route or a path, URL path. But as you know that in this instances, I don't have any website or all this document present in there. So I am skipping this health check. What you can do, you can put resources into your instances and make it work like a web server. You can do it for yourself, and then you can add the health check path. So you can do a detailed lab in which you are setting up your EC2 instances, then you are also creating some resource file in your EC2 instances. And then what you are doing, you are doing the load balancing. Afterwards, you can do the health check also. But if I start doing like for health check, I have to do the setup, but I don't have the setup. So you can create the setup for yourself, and if you find any difficulty, you can let me know. But I have already told you what the health check is for. It is just to specify if our web server is responding towards the request or not. Okay. So right now we don't have any instances with us, so we are not selecting. This is an optional step to create. However, ensure that load balancer route traffic is to the target group. Must register your targets. Okay, so we are now just creating the target group. We will specify our target in the later slide. So let's see if we have our target group now with us or not. We have, this is what we have created, right guys? Okay, let's check. So what are the different information we have? Details, you can check out the tab of for details. Instance, target type, we have selected instance target type, but you know that we have not attached any instances yet. Okay, so protocol TCP, it is listening to TCP on which port? 80. I want that it should listen on 443. I can do that, but 80 is fine. But the like, I'm not using it for anything else. So let's use it for TCP. So over here, you can see total target, zero target. So we don't have any target attached. That means it is also show. Let's say if we have three EC2 instances, and over here that will show the number of three. If we have attached three instances with this target group, those three instances are our target. Now, guys, it will also show you if they are healthy, unhealthy, unused, initial, and draining. You can know the performance. You can know what are the condition of your instances. Okay, so register target, you can register your targets from this tab. So first of all, we have to create some EC2 instances so we can register them. Monitoring, you can also do the monitoring very well. Health check, I told you, for health check you just have to add a path, a URL, a way to ping, just to make sure that you know if they are working or not. Okay, tags attribute is just adding some extra information. So let's create our EC2 first. So you see, I have one instance already running. It is the part of my previous target group. So let's create two new instances and attach them with the current target group we have just created. So we are launching two instances, guys. Let me launch first one. T1 target 1. Let's select the key. So I already have one key with me, so I'm not gonna create the another one. Let's edit the network setting informations. Okay, so this one is my default VPC. I want my VPC to be attached with this instance, and a public subnet is there. Public IP, we will enable it. Okay, so it is creating a security group. So make sure, guys, whenever you are configuring, make sure when we talk about web server, what are the qualities of web server? It is available to the public. So you see, if I am creating this if I'm launching this particular instance, and I want it to act like a web server, so do you think that only allowing RDP connection will give me that kind of functionality? No, it will not. So I have to allow other security rules. Okay, so I have to attach security rules. So you can attach according to the organization and according to the information available to you. But right now, what we have done, we want TCP to be work on a port 80. Okay, so we will be configuring that. Source anywhere, because we want it to be available for public. So we have one rule for RDP, guys. We have one rule for our TCP. Now launch. Okay, so it's showing me that I'm excluding the free dial limit. Let me just free dial eligible. Okay. So we are back in the VPC, guys. It is telling me that I have to change my subnet and the availability zone of my subnet. So let's coming back and it's in the different zone. So we will create a new subnet, availability zone 1P. So I think it should work now. It eligible. Let's try to launch this instance. Sure. Okay, now it's launching. So it was just showing that the availability zone we have picked is the wrong one. Amazon is not providing the service in 1C, so we have to select the A1. Okay, so you can see our target group instance is there. Let's see if we have the instance. Okay, it's in the pending state. Let's launch the another one. So guys, I like earlier also we have selected the same subnet, but it was not working for this. So if best practice, if you have two subnet, create the resources in different sub availability zones. But for one particular availability zone, we are not able to launch the instance because the AWS policies. So let's use the same zone, South A1. Okay, so enable. So we already have a security group with us, which is our wizard, this one, wizard 2, which we have configured earlier. So let's launch it. So G2 is our target group, guys, and we have to perform particular action. What kind of action we can perform? Okay. First thing, associate. We have to associate this with a new load balancer, and we can associate with the existing one. Register target. Now let's register the target first. If the EC2s are up and running, they would be available here to be registered. So I'm selecting both of these two. You can see there are many configuration you can do. Okay. Target. Select. So I have attached all the targets. Now let's see the details. Instances, two targets. They are right now not in use. Why not in use? Can anyone please tell me? Because we have just attached them. We haven't done any kind of configuration in our EC2. We haven't made any web page. We haven't declared it as a web server, guys. So that's why let's add the load balancer. So you can do it two way. You can create a load balancer from here, or you can go to your target group again, select the target group, and then associate with new load balancer. Okay. So basic configuration. Over here, you guys can see the basic understanding how elastic load balancers are working. You have your VPC, then in which you have your network load balancer, and it is then distributing the request if you want to send it to the EC2, if you want to send it to the ALB, if you want to send it to another service. Okay. So now it is know how to distribute it. So let's read it. Create network load balancer. The network load balancer distribute income TCP UDP traffic across multiple targets such as Amazon EC2 instances, microservices, and containers. Guys, we have not discussed any microservice and containers, so that's why it will create a kind of doubt. But just understand they are just like service. So we are using a service, and by the help of load balancer we are making sure that there is a high availability. If there any kind of service that is facing high demand, automatically if there is another deployment is there, automatically what will happen, load balancer will check who is available to response now. Okay. Then when the load balancer revise a connection request, it helps the target based on on the port protocol and port that are specified in the listener configuration. In the listener configuration, we have to specify on which port and what protocol we want to listen. And the routing rules specify as default action. So route tables, network ACLs, they are all working on default, but your security group should be you have to make changes in your security group. If you don't make any changes, if you don't add the HTTP and other TCP ports, what will happen, you can only RDP, other network requests will be disclosed. Okay. So now, how elastic load balancing work? Client make request to your application. Client is the customer. He is making a request to your application. The load balancer receive the request either directly or through a endpoint of private connectivity via AWS private link. So this is another feature we have not discussed this, but okay, let's try to just remember this, that this is another kind of feature. So either the load balancer is receiving the request directly or through the endpoint. Okay. The listener in your load balancer, so the listener part of your load balancer receive the request of matching protocol and port, and routes these requests based on the default action. So what if the request is not matching, guys? Any guesses? It is load balancer is catching the matching request, the protocol we have mentioned. If we haven't mentioned any protocol, then what will happen? It will not catch the request. It will drop them. It will start dropping them.
So default action we have to specify, or there is by default a
I'm sorry, please repeat yourself.
we have to specify the default action, or it was automatically created.
Sorry again, can you repeat? I didn't heard the few first word. What you said?
We have to define or create the default action, or it will be automatically created for us.
Okay, the default action is this: whatever you have not mentioned will not go through. Okay, so if you have mentioned TCP, we are listening for TCP and we are listening for HTTP and HTTPS. So other requests will not go forward. Okay, they will the load balancer will not forward it. It will start dropping it. In load balancer, guys, let me just open up the paint. Guys, what we have a simple load balancer. Okay, so every request will first hit its listener port. So the listener port of load balancer, what will it check for? It will check for all the mentioned ruled. If we have mentioned that listen for TCP, and TCP what port? 80, port 80. So it will only listen for TCP protocol coming onto the port 80. Otherwise, it will start dropping all the other requests. So by default, it drop the other requests and only accept the matching request. Any further doubt, guys, in the configuration of load balancing? Guys,
Mm.
yes, guys, please let me know.
No, it is clear.
I'm sorry, what?
Yeah, clear. It is
Okay, good. Yes, so the listener in your load balancer receive request for matching protocol and port routed towards the target. Request based on the default action you specify. You can use TCL listener to offload the work, encryption, decryption on your to your load balancer. Okay, TCL facilities is also there. You can see healthy target in one or more target group receive traffic according to the flow hash algorithm. So it's just going into the details. This is not what we have to focus on. Let's do the configuration. So first of all, my load balancer, this is the name, internet facing. So if you have multiple server that are working within your in within your organization, and lot of resources are going from here and there, and so what is happening? Whenever there is a server, there's a chance of failing. The server always have a chance of failing. That's why you have two possible ways: internet facing and internal facing. So I am doing the internet facing. Internal facing are meant to be very top end clients who have very internal communication, who have very high level of internal communication. So VPC, let's select a VPC, my VPC mapping. Okay, so there's another option we haven't discussed yet, which is mapping. Select at least one availability zone and one subnet. For each zone, we recommend selecting at least two availability zone. The load balancer will route traffic only towards target. So it is just telling us to select the zone. So I'm selecting the same zone we have our instances in. So security group, we have not created any security group. Default is this one, but let's go with.
In the previous configuration, it told us that it doesn't have any internet gateway, public internet gateway.
Which one?
It is the above.
I didn't get what are you talking about. I have created the internet gateway by myself and then attach it with my VPC. You see over there,
Same is the same subnet.
lot of breakage, guys, due to the network. Please write down your question. I'm not able to hear you out properly. Is it the same case with me also? Are you guys not able to hear me out properly?
No, your voice is clear.
Okay. So what I understood, you are asking that we have not attached the internet gateway. This VPC is without the internet gateway, but if you remember, I have created this gateway by myself and then attached it. Action.
Where we are doing the configuration, it is showing information.
Yes, over here. The select subnet does not have a route to internet gateway. This means that your load balancer will not receive internet traffic. You can proceed with this selection. However, for the internet traffic to reach your load balancer, you must update the subnet route table. So that's the thing, subnet route table. We have default route tables also. So which one does has the internet connectivity? Let's check out. So according to me, both of them should have because I have attached the internet gateway. Local black. Why? Route table and it is associated with which subnet? No subnet association. This one. Okay. So let's go back to the route table again. Does it have the internet route? Local only. Listener, make sure, guys, that you always remember whatever port you are using and the protocol. Okay, so we have only right now we are just doing the lab, and for the lab purpose and to make it more easy, we are just using one protocol and one port. Okay, default action. Select the target group G2. So if you want to add some additional tag, some naming, you can do that from here. So summary, basic information you can oversee. Internet facing IPv4, security group is this, VPC is this. Now let's create the load balancer. View load balancer. My load balancer. Let's check out the, it's in the state of running. It's like it will take some time. So VPC, availability zone, IPv4. We have listener, which listener? TCP/80 only. Network mapping, you can check out. Security group, this particular security group. Okay, now coming to the auto scaling. Now, guys, you have understood how to create target groups and how to attach load balancer. Any kind of difficulty, please let me know. One more thing, let me check in the load balancers. Compare load balancers. Over here, guys, please see there are the different load balancers. One is called application load balancer, network load balancer, gateway load balancer, and the very like this is not in use right now, very uncommon, but classic load balancer. So you can understand, you can go and search for more info, you can check it out, compare and select load balancer type. Okay, application load balancer, choose an application load balancer when you need a flexible feature set for your application with HTTP and HTTPS traffic. Okay, choose a network load balancer when you need ultra high performance, TLS, if you want security. Okay, if you want the encryption and decryption facilities, network. Okay, then gateway, choose a gateway load balancer when you need when you need to deploy and manage fleet of third party virtual application. Got it, guys? When you are running virtual application, gateway will be the best option for you. So uh, yes, guys, check out more info about them. There's nothing complicated, you can understand them. Now coming to the another topic, auto scaling. So you don't have to do anything in the auto scaling, you just have to attach the image. So when we are attaching the image, we can create attach our own image. I told you how to create the image, how to create the snapshot. If you want to save some particular configuration, you can create your own image and you can attach that image into the auto scaling. So whenever you don't have to launch a new image without any features, you can launch the similar image, and that particular instances will be working like the all other instances in the group. So the configuration, you don't have to do that again. So check this out by yourself. Maximum pricing over here, what is it is also scaling, is started with auto scaling. Over here, check this out, guys, you can study this tutorial from this one. You can configure your auto scaling. Okay, so for further information, refer to the docs. Now I am just quickly configuring my auto scaling. Okay, launch template. Now I have to select the launch template. So I told you, if you have any image, you can select it. But if you don't have any image, then you will not be able to select it from here. So let's create our launch template first. Hmm. My AMI. MM. Okay, guys, like AMI is also be needed. So you can see I have explained each and everything regarding, but there is just step by step you have to follow. So just auto scaling, go to the auto scaling and try to do the auto scaling by yourself. Otherwise, we will do it tomorrow. I will be showing it to you tomorrow. If you have any doubt, please collect your doubt and bring it to me tomorrow. Right now, you can see for auto scaling, we have to create the AMI image, then other extra step we have to do. But it is a very simple process. You just have to create the auto scaling group in which you have to include the maximum and the minimum, your minimum and maximum conditions. So we will do it tomorrow. Let's just, okay, yes. So we have understood auto scaling and the only lab is left to do. So we will do the lab tomorrow. Any doubt till now, guys?
Why it is called elastic load balancing? Why not
It
just
just
load balancing?
it's their way of pronouncing it. You see, elastic block storage. Elastic is that's way of telling that they are very flexible. If you want more storage, it is elastic. And we talk about load balancing, it is also elastic. So you can attach less server, more server. You can do multiple things. You can use application. You can use network load balancing feature. You can use gateway load balancing feature. So it just their way of telling you that their facilities are very, very elastic and flexible.
Okay.
Yes. Any other doubt, guys? Okay. Well done. So we have covered two topics: network load balancer and auto scaling. Load balancer and auto scaling. So these are very two important topic. We will do the lab for auto scaling tomorrow. And another thing, guys, our tomorrow's topic is S3. And till now we have been doing EC2, we have been doing VPC. So all together a new topic is coming, a new service. We will be seeing lot of new services, but S3 is one of the amazing service and it is the part of our basic course. So tomorrow we will be doing S3. So be on time, guys. Be prepared. S3, be excited. Okay. So for now we have done EC2, VPC, and we will cover S3 also. So guys, any doubt till now, please let me know.
No, no.
And guys, you can try to configure, you can try configuring the auto scaling group by yourself. It is very easy. You just have to follow the guide, like follow the all the step like I am following. It's very easy. It just I don't have a image ready. So what you have to do, you have to create the image of your EC2 instances. I have shown you how to create the image. So this will be your homework lab, guys. First you will be creating an image, then you will be creating your template. Afterwards you will be attaching that to your auto scaling. Okay, if you find any kind of difficulty, note that down. I will let you know what you do after that. Okay, but it is very easy, guys. Like frankly telling you, it is very easy. Once you start doing it, you will understand. It is very easy. You just have to select some configuration, select some templates, and then set up the CPU unit. How much CPU utilization is the danger for you, and if the CPU utilization is lesser than this particular point, then we can easily shut down our extra resources. So this is what you all have to do: practice, 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 practice load balancing, practice auto scaling. If you are not able to do the configuration for auto scaling, we will revise that in the tomorrow lab. Otherwise we will move forward to with S3. Okay,